Hey, good to see you again. In this video, I'm going to be showing you guys all about 5.1 fundamental trig identities. Basically, all this is we're going to be proving and simplifying and doing all sorts of crazy things with identities. So what I'm going to do first is kind of just give you all the identities that are really important. So these first ones, hopefully you've seen these before. I know we've seen tangent sine over cosine because don't forget tangent was y over x in our unit circle. So y was the sine, x was the cosine. Cotangent is tangent flipped, so cosine over sine. All of these we have also seen before. These ones, and your tangent and cotangent are going to be used way more than the other ones, so really make sure that you get these ones down first. Next identity that I'm going to talk about is the Pythagorean identity. And basically what that means is from our unit circle we know the equation was x squared plus y squared equals 1. Well, this is also a Pythagorean theorem because, I mean, if I pick any point on the circle, I have an x part, I have a y part, and my radius was always 1. So no matter where I am on the circle, I always have x squared plus y squared equals 1. Well, the x is cosine, so I have cosine squared plus sine squared theta equals 1. This right here is your Pythagorean identity. There are two others that kind of go with it. And the way that we get to those is if we take our Pythagorean identity, cosine squared theta plus sine squared theta, and we kind of just mess with it a little bit. If we say if we divide everything by cosine squared theta, I'm not changing the values of anything. I'm not changing much at all really, except for the way that this thing looks. Okay, once I do that, cosine divided by cosine is 1. Sine over cosine, that's tangent, and this will be secant. So I can say this is 1 plus tangent squared theta equals secant squared theta. That is another identity that you will have to know how to work with. Okay, the other way is just like I divided by cosine, you can also divide by sine squared on all of them. So that you have from your Pythagorean identity cosine squared theta plus sine squared theta equals 1. Divide all of them by sine squared theta, and sine squared theta. So there's our 1. Cosine divided by sine, this is cotangent squared theta. That was 1, and I have 1 over sine squared theta is cosecant squared theta. Okay, those are 3 more identities that really come from this one, but you have to know how to use all 3. Alright, we also have another group of identities called cofunction identities. So it's kind of the function that just goes with the other one. But basically, I'm going to kind of walk you guys through this first one and then I'll just list the other ones. But this is a little bit difficult to understand sometimes. Because if we have sine of pi over 2 minus theta, all of this in here is saying sine of some angle. But this angle is pi over 2 minus theta. Say we have theta. We know this is 90 degrees. Pi over 2 really stands for 90 degrees. So if I've already used up 90 degrees with this angle right here in my triangle, then between this angle and the theta, we have 90 degrees total. Well, if I say 90 degrees minus this angle, it's minus my theta, that's going to give me this angle right here, whatever it may be. Say I call it beta. So really, this is saying sine of beta. Well, if I go sine of beta, say I have this side over this side then, from theta, so in terms of theta, I get these two sides by using cosine. So there is my cofunction identity. Sine of pi over 2 minus theta is cosine of theta. Okay, take a second, look at it, and I'm going to write all the other ones up here. Oh! There they are. Magic. Okay, so these are all of your cofunction identities. You're not going to... these are not nearly as important as the previous ones that I've showed you. The Pythagorean identity is very, very important, as well as the first fundamental identities that I showed you. Okay, make sure you really understand those. Okay, and these are just a reminder of your even and odd functions. These are things that we went over in the previous unit, in Unit 4, with graphing and all that stuff. Okay, make sure you know these. Make sure you still remember them. They are going to be used as well. I know this is kind of daunting for you guys to try to remember all these identities, but don't forget most of them you already know. And what I would do in order to kind of get them down a little bit easier is just make some flashcards or something. Just turn one over. Whoa, what's sine of negative theta? Oh, it's negative sine of theta. Okay, so just use flashcards. You guys know how to use flashcards. Just make sure you're using your study tools appropriately. Okay, the first part of this section, you guys are going to see some examples like this, where it's asking for the other 4 trig functions. Really, we already have 2 of them. We should be able to find cosine and cosecant pretty easily. The only ones that are going to be a problem are cotangent and tangent. So what I would do first is draw your triangle, pick an angle as theta, doesn't matter which one. Okay, now secant, I know, is hypotenuse over adjacent because it's related to cosine. So this is like square root 2 over 1, and sine is opposite over hypotenuse. But check it out. I do not have the same hypotenuse. However, I have a 2 on bottom and a square root 2 on top, so it looks like this thing was rationalized. So if I kind of unrationalize it, this is like negative 1 over root 2. So by secant, I have the hypotenuse is square root 2, the adjacent is 1, so 1 and square root 2, and then sine is negative 1 over 2, so the opposite is negative 1 over square root 2. So there we go. Okay, the other functions then, I'm going to list them out. Oh, man, good today. I'm writing all fast. And here we go. So with cosine, that is the opposite of secant, so I have 1 over square root 2. And anymore, I really don't care if you leave square root 2 on bottom. That's fine. It's not a big deal. We have calculators now in order to calculate square root of 2. Tangent, I have opposite over adjacent, so I have negative 1 over 1. So that'll be negative 1, just like cotangent will be negative 1. And for cosecant, I have sine flipped. So when I flip this one, I will have negative square root 2 over 1, which will then just be negative square root 2. And there's our 4 other trig functions. Alright, so the biggest ones that you're going to see in this section, and the things that I really want you to focus on and understand are, that's supposed to say like that, simplify, are ones like this, where it gives you some functions in whatever fashion or order they may be in, and you're going to have to simplify. This is kind of like when we were expanding and condensing our logarithmic functions and exponential functions and stuff like that, except you're going to try to get these down into as little trigonometric functions as possible. And when in doubt, sine and cosine it out. And what that means is just write everything in terms of sine and cosine that you possibly can. Because here, I don't really know that these go together other than it just tells me. So secant, however, I know that this is 1 over cosine. So if I substitute in 1 over cosine for secant, and I'm multiplying it by cosine, well, this is kind of like cosine over 1. So when I multiply these things, I will have cosine of x over cosine x. Well, that's 1, so this whole thing is just 1. Alright, same instructions, just simplify these things. It's going to be really important now that you guys know your identities well. And again, just know your identities. If you know your identities, just substitute stuff in. When in doubt, sine and cosine it out. So tangent, in terms of sine and cosine, is sine over cosine. And cosecant is 1 over sine. Well, after I have sine and cosine it out, it looks like that I have sine divided by sine is 1, so I'm just left with 1 over cosine x, which I know is secant of x. I have it down to as few terms as possible, and there it is simplified. Tomatino! Okay, doing the same thing again. This time we're doing secant squared x minus 1 over sine squared x. Well, I know that secant squared x is 1 over cosine squared, but that doesn't really help me that much. However, if I think of my Pythagorean identities, because those are the only ones with squared in it, and I have squareds, then maybe I'll get to the right answer. So don't forget about this Pythagorean identity right here. And notice, I have secant squared x minus 1. Well, I can replace in tangent squared x plus 1 for secant squared, and the ones will go away. Or you can just make it look like secant squared x minus 1 by moving over your 1 and saying that tangent squared x is the same thing as secant squared x minus 1. You're just moving around your identity so it'll match something in the thing you're trying to simplify. So here, since I know that tangent squared x is the same thing as secant squared x minus 1, and this is in my equation, I'm going to substitute tangent squared x for what I know it to be. So tangent squared x over sine squared x. Well, I know tangent squared is sine over cosine, so sine squared x over cosine squared x, all over sine squared x. Okay, all I did was make tangent x sine squared x over cosine squared x. And then to get rid of this fraction, I can multiply both sides by 1 over sine squared x and 1 over sine squared x, so that this goes away on bottom. And then check it out. Sine squared divided by sine squared is 1, so this whole thing is 1 over, hoops, banana, hot pie. Oh no, come on, eraser. Eraser! If only we had a real eraser. Then I could erase, I don't know. I don't really know where I'm going with that. So I have 1 over cosine squared x. And then 1 over cosine squared, well, that's secant, so secant squared x. Oh no. Oh no. There we go. Happy day. Alright, I got another example for you. Again, this is already in cosine and sine, so I can't really do much there. But I have a squared, so I'm going to think of my Pythagorean identity. I have cosine squared theta plus sine squared theta equals 1. And look, to get cosine squared by itself, I can subtract sine squared to both sides. So there's 0. So I have 1 minus sine squared is cosine squared. So I'm going to substitute that in since I have a sine on the bottom. So now this turns into 1 minus sine squared theta over 1 minus sine theta. On top, I have a perfect square with the 1 because I know 1 times 1. I have sine times sine will give me sine squared, minus in the middle. So this is actually a difference of squares. So this is 1 plus sine theta and 1 minus sine theta all over 1 minus sine theta. Well, check that out. 1 minus sine theta and 1 minus sine theta go away, so I'm just left with 1 plus sine theta. And there she is. She's cute. Ask her out on a date. See if you can get her number. Haha, I bet her number is 1. Hee hee. Alright, I'm going to do one more example with you guys because I love you so much. So in this one, I have a bunch of squareds. And I have a secant squared. I know this is 1 over cosine squared. Or I can just factor out sine squared from both terms, which is what I would do. So I'll show you 2 different ways to do this one. So if I have sine squared x, and I factor it out, then I'll have 1 minus, oh no, that's not right. I will have secant squared x minus 1. I know that this right there, that is tangent x by our Pythagorean identity. So then I have sine squared x, tangent squared x. Tangent is sine over cosine, so if I multiply this out, I would have like sine to the 4th over cosine squared, so I don't really want to do that, so I'm just going to leave that just like that. That looks about as simple as I can get it. So sine squared, tangent squared x. So let's try this another way. There's plenty of different ways to do these problems. So if I change this into 1 over cosine, then I'll have sine squared x times 1 over cosine squared x minus sine squared x. Okay, well, I know that these two will multiply to be sine squared and sine squared over cosine squared, which will be tangent squared. So I'll have tangent squared x minus sine squared x. And I'm actually just going to leave it as sine over cosine, because I want to get these terms together. So I have sine squared x over cosine squared x. And in order to add these things, I need to have a common denominator. Granted, some ways that I do problems, or not that I do, but that you try to do problems will be a little bit complicated in other ways. So really knowing these fundamental identities will help you out a ton. So if I need a common denominator, this sine squared x is like it's over 1. So let's make it over cosine squared. So if I multiply top and bottom by cosine squared x and cosine squared x, then I will have sine squared x over cosine squared x still, minus sine squared x cosine squared x over cosine squared x. And really this isn't looking like it's getting me anywhere at all. because then this would get me to sine squared x minus sine squared x cosine squared x all over cosine squared x, which really I would just have to factor out the sine squared x again, just like I did in the original equation, and then it would only get me to this point right here. So in these, I guess it looks like if you need to, or if you see something with similar terms, factor it out first and see what happens. Okay, hopefully this video is helpful, and I wish you all a wonderful evening. Hopefully you get some good sleep. If you weren't sleeping already through this entire thing, I apologize if you were, but maybe that'll wake you up. Good night.